Okay, so we're continuing on some work with page 294. We just did number 2. Now I'm going to move on to number 3 and do the same exact steps. The only difference is now we have 2 quadratics instead of 2 linear equations. But the same rules apply. We're adding them, subtracting them, multiplying them, and then dividing them eventually too. So f of x is equal to 2x squared minus x, and g of x is equal to x squared minus 4. So if we add the two functions together, that should be pretty easy. So f plus g of x is equal to the f function, 2x squared minus x, plus the g function, x squared minus 4. Combining like terms, 2x squared plus 1x squared gives us 3x squared. And then a negative x and no other x's just gives us 1 negative x. And then a negative 4 and no other constant values gives us negative 4. So here is our composite function, not composite function, sorry. Here's our function when we add the two of them together. Now subtracting, so f minus g of x. We take the f function, that's the leading one, so 2x squared minus x, and then subtract away the entirety of the g function, so we put that in parentheses, x squared minus 4. So distribute the negative in there, 2x squared minus x squared, and then plus 4, and then combine like terms. 2x squared minus x squared is x squared, and we have a minus x, and then a plus 4, and we can't combine terms any longer, so that's it. Now for multiplication, f times g of x. So we get 2x squared minus x, and also x squared minus 4, and then FOIL or distribute, so 2x squared times x squared gives you 2x, and then square times the square gives you to the 4th power, so 2x to the 4th. 2x squared times negative 4 is going to give you a negative 8x squared. Negative x times x squared is going to give you a negative x to the 3rd. And negative x times negative 4 is going to give you a positive 4x. So we actually can't combine any terms from there, so we're just going to write it out in order from the greatest exponent to the lowest. So 2x to the 4th minus x to the 3rd, and then minus 8x squared, and then plus 4x. And that's it. So there's our multiplying operation, and then we've got division. That's our last one, f over g of x. So the f function goes on top, the g function goes on the bottom, so that's pretty easy, just 2x squared minus x, and then in the bottom it's going to be x squared minus 4. Okay, so first we want to find our domain, because it looks like there's some stuff that we potentially could cancel out. We're going to check to see if we can, and I'll show you how to do that in a second. So our domain first, x squared minus 4, since it's a rational function, the domain cannot be equal to 0. So then we solve for x. So we add 4 to both sides. X squared cannot be equal to positive 4. Take the square root of both sides. X cannot be equal to plus or minus 2. Because remember, when you take the square root of a squared variable, you have to account for the plus or the positive or negative solutions there. So there's our domain. Now let's see how we can mess around with this. Because when we have quadratics, we can factor them. And every now and then, when you factor, you're going to be able to cancel binomial terms out. So let's see what happens. I know that with the 2x squared and the x, they both have x's in common, so I'm going to factor out an x. So if I factor out an x from this, then this 2x squared becomes just simply 2x, and this negative x becomes just a negative 1 if I divide the x out, or factor it out using distribution. This x squared minus 4 is a difference of squares quadratic, so that means that it factors real easily. We just take the square root of both values. Square root of x squared is x, square root of 4 is 2, so we go x plus 2, x minus 2. And this is our entire factored out expression. Every now and then you'll end up with something like this, where it'd be like, the x minus 2 being the top, so you can cancel them out. But this particular case, it doesn't work out, so we just leave it as is, because nothing cancels out in the top or the bottom, and that's our division operation. Okay, so that's number 3. I think that between number 2 and number 3, that sets a pretty good precedent for like how you should do these problems right over here. Now we're going to move on to this next section and do maybe a couple from there.